Today we're covering 5-6, which is the quadratic formula. So we're going to go over that and we're going to look at the discriminant. I'll define that and see how we can use it to figure out the number and type of roots a quadratic equation has. So here is the quadratic formula. They have it negative b plus or minus the square root of b squared minus 4ac over 2a. I usually tend to use it like this, so I break up the two rational expressions to this, but either way is fine. So I'll divide negative b by 2a and then do my plus or minus square root of b squared minus 4ac over 2a. Whichever you prefer is fine. So we can use the quadratic formula for any quadratic equation. So if you get a quadratic equation, you can't factor it, you don't see a good way to solve it, quadratic formula always works. And you need to make sure first it's written in standard form because we need to properly identify our a, b, and c, and we will get real or complex solutions. So first example, find the zeros of f of x equal 2x squared minus 16x plus 27. First of all, we want to make sure it's in standard form, which this one is. It has everything over on one side of the equation. So we're going to set it equal to 0 to find our roots. And then we're going to identify our a, b, and c so we can plug them into the formula. So here's the formula. Our a in this case is 2. Our b is equal to negative 16 and our c is equal to 27. We will plug them in, get negative of a negative 16 plus or minus the square root of negative 16 squared minus 4 times 2 times 27 over 2 times 2. Make your calculations. Just be careful. Preserve your order of operations. So you're going to square here first before you do this and multiply this before you do any subtraction, and then after the subtraction you square root it. This is what we get. We're going to end up with this, and then 256 minus 16 gives us the square root of 40. And at this point you can see I would well, as I said, I normally do break it up. 16 divided by 4 is 4. And then we're going to rationalize this. 4 times 10, 2 times 2. This will not simplify to a pair of factors, so this square root of 40 simplifies into 2 times the square root of 10 over 4. And notice we can simplify this to divide a 2 out of this and this to get down to the square root of 10 if we do over 2. So this would be our final solution, 4 plus or minus the square root of 10 over 2. Don't turn it into a decimal, leave it as a radical expression because we want the exact answer. All right, so you should try this one. Let's look at the next example. Solve the equation. 9x squared plus 25 equals 0. Whoops, sorry. This should not be part of this lesson. So we are going to move on. And here's another example. Find the zeros of f of x equals 4x squared plus 3x plus 2 using quadratic formula. Again, check to see if it's in standard form. In this case it is. Set that equal to 0. And then we want to identify our a, b, and c. A is 4, b is 3, c is 2. Plug them in. And we get this. Notice here, underneath our square root, we're going to end up with 9 minus 32. So we're going to have an imaginary solution or an imaginary number which is going to make for a complex solution. So 9 minus 32 is a negative 23. And remember, we rewrite this as the square root of 23 times I So it ends up being negative 3 over 8 plus or minus the square root of 23I over 8. So quadratic formula just as easily finds complex solutions as real solutions. All right, we're going to look at the discriminant. So this part here underneath the radical, underneath the square root, is called our discriminant. And depending on the value of that, we can figure out how many solutions we're going to have and if they're real or complex. So let's look at, well, first of all, the discriminant is part of the quadratic formula that we can use to determine the number of real roots of a quadratic equation. And here's the rule, and this is a nice picture because it kind of shows you if you have a graph like this where you have two x-intercepts, you're going to have two distinct real solutions. If we have a graph like this where the vertex is on the x-axis, that gives us one real solution, distinct solution. And if we have this case where we have no x-intercepts, this is the case where we're getting the complex solutions. So how does the discriminant help us figure this out? Well, here's the rule. If the discriminant, and that's the part underneath the square root, if you calculate it's greater than 0, then you will have two distinct real solutions. If you calculate b squared minus 4ac and it equals 0, then you will only have one distinct real solution. And if you calculate the discriminant b squared minus 4ac and it's less than 0, that means you're going to have two non-real or complex solutions. And again, before you do any of this, to properly identify your a, b, and c, you need to make sure that the equation's in standard form. All right. So let's look at examples of this. Find the type and number of solutions for the equation. So again, first thing you want to do, standard form. This is not in standard form, so we're going to move everything over. Whoops. Move everything over. We want to keep the x squared positive, so I'm going to move this over here by subtracting 12x. And now my a is equal to 1, my b is equal to negative 12, and my c is equal to 36. So I'm going to plug it just into the part underneath the square root, which is b squared minus 4ac. So if I plug the b and the a and the c into that, I end up with 144 equals, or minus 144, which is going to be 0. The rule says if b squared minus 4az equals 0, we're going to have one distinct real solution. And that would be our answer. All right, next one. It looks pretty similar, but it's different. So again, we've got to put it in standard form first. So we're going to subtract our 12x. Now we have an a equals 1, a b equals negative 12, and a c is equal to 40. And you can probably guess what's going to happen this time. If we plug it into our discriminant, we're going to end up with 146 equals negative 1, or minus 160, which is equal to negative 16. Since the discriminant's less than 0, it has two distinct non-real complex solutions. I'm happy if you say two complex solutions. That's good enough for me. They say non-real because complex does include real solutions. So non-real differentiates between real complex and non-real complex, if you have that question. All right, this is one for you to try. And now I'm going to summarize the different types or different ways we have for solving quadratic equations, because that's probably, it's all kind of mixed up and confusing. This is a nice way, a nice summary of everything. So properties of solving quadratic equations, graphing only. So you only get approximate solutions, even if you graph by hand or graph on the graphing calculator. It's a good quick way to do things, but if you want exact answers, it's not really as good. Factoring. So this is the case where you might want to factor. If c is 0, or the expression is easily factorable. Actually, the other case would be if a is equal to 1. So if you don't have a number in front of your x squared term, that would be a case where you might want to use factoring. And when c is equal to 0, this means you're going to use greatest common factor. So it's a case like 3x squared plus x, where we can factor an x out of both of those. Square roots. So the variable side of the equation is a perfect square. So whether you have x squared equals 24 or x minus 5 squared. So if you can factor something into a binomial, a squared binomial, then that might be a case where square rooting would be a good choice. Okay, completing the square. When would you want to use it? Well, when a is 1, so we're not going to deal with cases where a is not 1. And b is an even number. So it's a lot easier if you can divide b evenly by 2. And that's a case where completing the square might be a good choice. You could use quadratic formula on these as well, but quadratic formula has its own issues. It's a lot of calculations and it's easy to make mistakes on that. Okay, quadratic formula, numbers are large or complicated, the expression does not factor easily. Any other time, if you can't see using factoring or completing the square or square rooting, quadratic formula is your choice. It will solve any kind of problem. All right, here's your homework. Bring any questions to class.